Ladies and gentlemen, good evening. Tonight we're going to look into Docker basic stuff. So if you already know Docker, then this video is not for you. But if you are a beginner with Docker, then this video is definitely something for you. Or if you have heard about Docker, but you really don't know how to get started, then this video is also something for you. Docker is a virtualization technology. It's an engine. So it's like you have a virtual machine. Whenever you spin up a container, as it's called, that is it's like your virtual machine. But the container is always based on an image. The image is like if you have a virtual machine and you take a snapshot inside your virtual machine, then that will be the image when you are talking about Docker. But Docker it's not the same as a virtual machine because it has a much smaller performance footprint. It uses much less CPU and memory. That means so you can have a lot of Dockers running on your own machine without actually having any performance issue. Many times you can have all of your third-party dependencies like databases, and maybe you need a rapid MQQ or something else, Apache Kafka or something like that. Then you can just spin it up inside on your own machine as Docker containers based on the Docker images that are provided usually by the official vendors. And that's the cool part. We can easily start up an application and then it just runs and But there's another usage for this, then that is that usually you have an application, maybe you have an application, a Java application that you have packed as a jar file. And it's cool, this every time you start up this jar file on your own machine, then it works perfectly fine. But you also want to make sure that it works the same way in production and on your colleague's machine, and that is why you would make something called a Docker file. The Docker file is kind of the recipe for how your Docker image should look, what your Docker image should look like, and inside your Docker file, you can actually copy your application inside the image. So your jar file or your application artifact, it can also be something else, of course, than the jar file, is then a part of the Docker image, and then it will be started inside this Docker container when it runs. Your Docker file, it always has to have the first line where it says which other Docker image is it based upon. There's a lot of popular choices, like Alpine has a very low size footprint, so it's very small, and that makes it it makes it perform very good when you use the Alpine. But you can also use Ubuntu if there's something that is not available for Alpine. Then you can use Ubuntu instead. Maybe you have something that is a bit too difficult to install with Alpine because it's such a lightweight operating system. Then you can use Ubuntu instead. I'll show you examples of this in just a couple of minutes. Yeah, so then we have our application, we have the Docker file, and then this will actually make up the Docker image. And the Docker image, when you build the Docker image based on the Docker file, then it will be placed on your local Docker registry, because you actually have a Docker registry locally. That's where it will be built and placed first. And then you probably want to place it on a remote registry where your production servers can actually access it, where your colleagues can access it. It's not uncommon that the company has a company Docker registry between different departments, so different departments actually can work together and take each other's Docker images and use those in the normal work and in the development process. So you have this Docker image that you want to push to an external Docker registry. And the keyword is push, and that is because the syntax is Docker push and the name of the image. Then you have your engine it might run on a production server or maybe on a test environment. It might be running on your colleague's machine, but you have a Docker engine that makes sure that when you spin up a container based on your image, then it runs exactly the same as if you would run it on your own machine. And that is actually the flow. So this drawing right here, it actually shows the flow that we usually use when we are taking advantage of the Docker technology. And it is an awesome technology, and you cannot get around it. If you don't know about Docker, then this is definitely now that you need to learn about it and how to use it on your local machine, at least to spin up third-party dependencies like databases. That's a drawing. Now let us look at some. First of all, I want to show you that you can get Docker for free, and it will take you a long time before you actually would need to get one of the paid versions where you can get some more support and you can have some access to a remote registry. You can actually start up a Docker registry inside a Docker Engin. So if you have a server that you want to, where you want to place your Docker registry on, then you can actually just spin up one of those there. And it is a bit like just taking an application down from the shelf when we talk about Docker, because there's something called the Docker Hub, and we can just search for whatever we want to search for. You can search for MySQL if you want a MySQL database, right? Then we can just then we will get some search results right here. And the ones marked with official image, those are the ones from the official vendor that they will actually maintain. Another thing that is good to look at is actually the number of downloads. If you have like 1 billion and 10,000 stars, then usually it is image that you can safely use. In the old days, in the beginning, when Docker was a bit younger, then there was a lot of there were some images where there were malware in them, and there was also like malicious software, like mining software, stuff like that inside the Docker images. But they have become much safer lately. But you should, of course, you should never trust 100% software that you get on the internet. But when they have this official image, then there's a big chance that there's no malicious software inside them. So Docker, hub.docker.com, you just go there if you need something that you need to start up on your machine. That's actually it. And what we are going to use to begin with to show how to start up a Docker container based on an image is actually the Nginx image that we have right here. Nginx is pretty cool. It is both a web server, but it's also a proxy server where you can proxy traffic to wherever you want to proxy it to. But we are going to use the HTML web server part of this for this demonstration right here. I am using VS Code from Microsoft. It is awesome. It's very lightweight, so it's very good to start up. Where you just have a folder and then you can just write code, and then when you stand inside the folder, there's also a lot of support for WSL, Windows Subsystem for Linux. That is what I'm running right here. I have I'm running Windows, and then I have Windows Subsystem for Linux installed on my Windows machine. I've made other videos about how to make that work. But this actually, what this gives me actually is that it gives us the benefit from the Linux world, so we can get SDK man to keep track of all of our SDKs. So it gives a lot of benefits that we are actually running on Linux and not directly on Windows. If you're using macOS, that's actually also based on Linux. So so that's also fine. If you're using Ubuntu, then of course you're also happy. Okay, so now let's get started. So I have this repeat.markdown. Markdown. This is actually, this is what I want, the topics that I want to go through, and this is what I hope to show you right now. I need to show the engine. That's what we just did with the drawing right there. Then we need to run something. That's what we're going to do now. Then we need to talk about port mapping. We need to build our own Docker image that can spray out hello world in the terminal. Then we want to run as a daemon. Then we want to attach and do some debugging. We want to attach to a running container. We want to mount some volumes so we don't lose our data whenever we are done. Having our container running. So when our container stops and then when we start it again, then we can actually have the files persisted in between those runs if we do some volume mounting. Then as the last thing, we want to optimize our Docker image so it actually it takes up less space and it performs much better. Yeah, so that's the agenda. So let me just close the right here. First of all, let's just get right into it. I'll write Docker run, and then I'll say Nginx, and actually, so this is actually the command to run a container based on an index on an image, and the image name is Nginx, and then I can actually give it a tag. You always write colon, and then you give it a tag. At the tag, you can actually place a specific version if you want to run a specific version of your software. Then you write it there. If you don't care and you just want latest, then you can write latest. But there's a small trick. If you don't, you can just leave out latest. If you just if you just mention the name, then colon latest that will automatically be chosen as a tag. Let us see what happens when we do this. If you don't have the image already, then it will actually download it. But since I've already run this before, then I already had the Docker image, and then it actually just starts up. So that means that right now I have a Docker image running on my machine, and the way I can see that is actually I have a container based on an image. That's what it's called. The container that is the running instance of the image right here. If you run docker ps, then you can see all of your running containers. If you run docker ps -a for all, then you also get the containers that I actually have been stopped. And here you can see the status in this column right here, and some of my containers right here that have been exited many days ago, so 2 days ago. And if you don't give your container a name, then a random name will actually be assigned to your container, but of course you can also name them if you really want to name them. Okay, so now let me go back to the first terminal. If I press Ctrl+C right now, then because this Docker run right here, it is actually attached to the terminal that I have, then I'm actually signaling that it should exit. I'm actually breaking whatever program that was running right there. That was the Nginx program that was running, so that means that now if I run docker ps, then there's no running containers right there. If I write docker ps -all, then I now have this container right here, which has been exited, and it's kind of the graveyard, because usually you would never start these. When a container first has been stopped, if you're not supposed to start again, you should actually delete them, and then if you want to, then you can spin up another container based on the same image. I'm going to clean up now. I'm going to write docker rm for remove, and then I can actually mention each of these IDs, container IDs that I have right here, or I can make a small trick where I write docker and then ps -aq. The q means that acquired, so that means that will only get the container IDs, and this means that when I run this command right here, then I'm deleting all of my containers like that. And that's the way I usually clean up my dead containers. But there's actually an even better way. When you start up your when you run an image and get a new container, then you can actually say that you wanted this to be cleaned up when the container exited, and you can do that by run -rm for remove, and then we take Nginx again like this. It's 2 minuses like this. Docker run -rm for remove. This means that now when I'm pressing Ctrl+C and we write docker ps -a, then it has already been cleaned up. The Docker container actually deleted itself automatically when we are done using it. And I would say this is best practice. You should always have -rm in your runs. Okay, so that's it. But now we want actually to access the HTTP protocol inside the container. How do we do that? We do that with port mappings. You can see there's actually on this file that I've opened right here, that I actually have a -p, then 8080, and then :80. This means that I'm mapping port 8080 from my own machine to port 80 inside the container that I'm running. Let us try to do something like that. I want to use another port than 8080. I just want to say run -it -interactive and terminal. I don't have to do that in this situation right here. I'll just write -p for port mapping, and then I'll say 80, 82, and then I'm going to map that to port 80, and then again Nginx like this. So now it's running. That means that I can now start my browser, write localhost, and then I can say 8082, and then I actually get some HTML presented. That's because now I'm actually accessing the Nginx application inside the container. I'm being routed, my traffic from 8082 is being routed to port 80 inside the container that we have right there. Per default, if you have a lot of containers, then they can actually see each other automatically on the default network. If they are placed on the default network, then they can see each other. They can access each other by using the Docker container name. That's how they usually. That's one way where they can connect to each other. You can also set up the network and have separate networks for some containers, so they can only see each other, and then you have other containers that can see themselves. So you can actually you can create different network groups if you want to. I will not cover networking in this video right here. Let us continue. So I'll press Control, and again here now we can see the log, because this is all the log output. That's what we are getting right here. I'll press Ctrl+C, so we actually close this one down right here. If I don't want to block a terminal, it's also there's a bit of risk combined with that, connected to that, because if I press Ctrl+C, then you saw my application is actually stopped. I don't want that. I just want to run it as a daemon, so I'm not blocking my terminal, and also so it doesn't, so I don't stop it by mistake. Then I write -d for daemon, and now my terminal is actually available, and I still get the HTML. If I refresh right here, it still works, but now it's just running as a daemon. So I can say Docker. If I want to connect to it, if I want to attach to it, maybe I want to do some debugging, then I can do that multiple ways. If I run attach, then I will end up in the same situation as before. Then I will actually be attached to the running terminal, to the running session. If I do this attach, let's try that to see what happens, and then we will go and refresh. We'll go and refresh our browser sometimes, and then we can see you get some output. This means now I'm actually attached to this Docker container just like before. If I press Ctrl+C now, then my Docker container will actually stop, just like before. So attach is one way to attach to the current session. There's a much better way if you want to debug or check some logs or something, and that is if you execute a command. You can execute a command. Let us just write Docker PS first. Docker exec for execute command. Here I want to write -it because that's for interactive and terminal. Then I get a terminal inside the container. And then I can mention the container ID. I can also use the name or the ID. It doesn't matter which one you use. And then I want to run bash inside my Nginx container right there. Bash. So now I'm actually inside this Nginx controller right here. And if you know something about Nginx, then you know that this is a Nginx folder right here. Then I can actually go and manipulate. I can also manipulate if I want to the configuration files just to try something out. Of course, I should never, if I want something here to be persistent, then I need to volume map. It, or I need to place it inside a Docker file. That is the best practice. You should never go inside a container and then fiddle with something, especially not in production. Of course, if you're developing something and you want to check something out, you want to try something out, then it's totally fine to do that, of course. And then when you've seen what kind of configuration actually works, then you can take that piece of configuration and place it inside your Docker file. Yeah, that's usually the way. I'm going to exit now, so if I want to get back to my own terminal, right here, then I press right exit. And you can see right now that the container is still running because I didn't stop the container. I was just started a new terminal session inside the Docker container, and then I ran some commands in there, like look up files with ls and so forth. Yeah, another thing. Let me just go back actually, because I want to do something. I want to create a new file called mic.txt. Here now I have a file inside my Docker container named mic.txt. If I exit and then if I say Docker stop and then the name, this time I'll use the name of the Docker container like this. Now my Docker container stops. Docker PS. So now it stops. If I now run it again like this, then if I list the files inside my if I list the files inside this Docker container right here, then you can see there's no mic.txt file right there. That's because I have not volume mapped anything inside this inside the container. Let us actually do some volume mapping, right? So we can see that actually works. I'll stop this one right here. Docker stop, and then ID, and then we will try to run again. Here we have our run command right here, and then this time I also want to do some volume mapping, and I do that with the -v for volume. Then I can give it a logical name. If I give it a logical name, then it is not mapped directly to my to the file system where I can access it easily. I can find it if I want to, but if it's something where you want to look into the files and you want to kind of play around with the files, or you want to check the files or something like that, then you would place it like some place on your own machine, like inside your home folder, home, MMN, first of all, this is my home folder, then you place something like Docker volumes, you create a folder like this, and then you could actually map that to Mike's folder inside the container like this. Then I can actually access the files and I can actually see them. I don't want to do that. I just want a logical name. This means that this logical name, Mike's vault, like this. And then into the, want to map that into Mike's folder inside the Nginx like this. This means that if I create a file, if I create a file in there, like docker exec, first of all, I actually have a folder right now. This folder would actually be created by default. It didn't exist. But when you volume map something, then the first thing Docker would actually check, does this folder exist already? If it does, then it will not create it. But if it doesn't, then it will actually create it. I'll go to Mike's folder like this. No files in here. Touch file 1.txt. Echo hello world to the file hello.txt. Like this. And then we can actually see that we have two files right there, and we have content inside the hello.txt. Now let us try to stop we will stop the Docker container right there, Docker stop, and then we will start a new one, run, blah, blah, blah. And again, I'm volume mapping this volume right in here. If I did not volume map this right here, I can map it actually to another folder in here, inside the new container that was spinning up. Then I can write Mike's another. And then we do like this and say Docker PS first, Docker PS like this. I'll take the ID again. And then I'll say Docker execute -IT. And yeah, of course, like this. And then we say that it's wrong ID. That's why I'm pausing right now. Yeah, that was. And then I write bash again like this. So let us see if I have a Mike's another in here. Then I go to Mike's another folder right here. And because we have volume mapped the exact same logical name as we took before, now we actually have two files right here. The files that we have actually manipulated and created just before. So that's how volume mapping works. You can actually create a logical name, volume, ls. I can list all of my volumes right here. I actually already had one that was named Mike's volume, and then I had this new one. I created Mike's vault right here. Of course, you can delete all of your volumes if you want to. That's up to you. Now, these are the basic stuff. Port mapping, volume mapping, to start as a daemon, to start as in the current terminal in interactive mode. Those are the default stuff. Now we want to actually create our own application, and that's why I've created this folder right here, Hello World. In my Hello World folder, then I have this Docker file right here, and it is good practice just to name it Docker file, unless you have a really good reason for not naming it the Docker file. Yeah, this is just kind of the standard. Now it is already from Alpine. That means it will get a very, very low size print. It will not take up a lot of space. If I used Ubuntu, then it would use like 100 megabytes. It would lead to an image of around 105 megabytes. If you use Alpine like I use right now, then you can end up like 5 megabytes instead. So that's a huge difference. That's like a times 20 times difference, right, between Alpine and like Ubuntu. So really try to use Alpine if you can. If you don't have any good excuse for not using Alpine, then use it. The second line regarding this from line right here, this means that we start from this image that we have right here. You can also start it from other images where Java is installed, for instance. That's also a thing you can do. And you can also start from scratch. That's very, very rare. That where you start where you start from scratch and then you put on your own operating system and all that. That is very rare. Usually you say from and then some kind of operating system like Ubuntu or Alpine or CentOS if you use that. Work here. I like to set this right here because this means that this is my working directory. This means that I'll actually place myself inside the the new Docker image that I'm creating, then it's like a change directory just inside the Docker image. That means that whenever I'm copying or doing something on the next line, then it is on the context that I'm inside this my application folder. Yeah. And the other thing with this work here right here is that if it does not exist, then the folder will be created automatically. So I don't need to run something like make dir. If you want to run something inside it, like a custom command, then you can write something like this: touch my file.txt or something like that. Then now we will actually create a file inside this folder right here. And when you use the run syntax right here and run command, then you can actually use a colon and a backslash, and then you can actually run multiple commands inside on this line right here. And the reason why that is good is because for each Docker command that you will have right here, then Docker will actually create a snapshot. It will create it is a snapshot, like a snapshot in time. And the more of those you have, the more space it actually takes up, and the longer it will actually also take to build your application. So best practice is to try to keep the snapshots and the steps to as few as possible. And you do that by using the run, and then you have colon, which separates each run, and then you have the backslash that means that this comes on the next line. So touch, and then other file.txt like this. Yeah, and that's it. And then we copy. The trick here is that now we pretend that this is our application. We've created this awesome application named echo hello world once.shell, and then I'm copying this inside the image, and I'm naming this my app.sh inside the image, which is totally okay. I can name it something else. And then in the end, I have an entry point. The entry point, that is when I run docker run and then my image name, what should actually happen. And this is exactly what is going to happen right here. It is a list. You can see right here, it's an array, a list of arguments, and every time you would usually write a space, then you would write a comma instead right here, and then you would write a new argument to be run. So this means that I will run shell chain, and I want to chain all of these commands that I'm running right here, and then I say my app sh. Of course, this means that then I could actually add something else right here, echo end of program or something like that. Or I could also say, yeah. So this is one way to do it. Let us see if this works. Actually, let us skip this. Then we can try it in the end to see if this works or not. This is the entry point right here. Then if I want to build this, then we have this docker command right here. Docker builds, and then a dot, because this is for the current directory. Let me just change my directory to hello world right here. Then I write docker builds, and then where is my Docker file located, in which directory? And this is the current directory, so I'll just write dot and -t for tag. This is my name, my Docker image, and then we can give it a good tag name like latest. I'll just give this latest here. You can also give it, of course, a real tag like I did in the other example up there. It's just built. While it is building, let me just tell you that inside the Docker file, you can only refer, when you copy files, you can only refer files that is in the same directory or in a deeper directory. You cannot go up, so you cannot like finding a file higher up in a hierarchy, like dot and then something like that. You just need to know that that's not possible with Docker. And another thing is, you will probably see add and then something else in some tutorials out there on the internet. Add has that feature that if it is a tarball, if it is some file .tar or .zip or something like that, then it would actually unzip that folder or that file somewhere where you actually place it. But if it's not a zip file, if it's just a txt file, then it actually then it works like copy, my file.txt, then it works like copy instead. So the best practice here is not to use add unless you want to use the unpacking feature, the extraction feature of the add. Use copy instead. Yes. Let's just see what happened here. Now we have, look right here, it was built now with a success. We also expected that, but let's just see here, Docker images. My Docker image, it has been built just like a minute ago. And look, it only takes up 5 megabytes because I am basing my whole Docker image on Alpine and not Ubuntu. I think Ubuntu is great, that's not it. It's just, the point is just that to try to keep your size as low as possible right here because it will perform much better when you are running it will take up less memory when you run your Docker container based on your Docker image. Let me now run this Docker run and then my image. Now I will not give it any tag name because then it will just take latest and latest is and it writes hello world. That is so nice. Let us just go here and see if the changes to my entry point actually would have worked. Let us see if this works. Maybe I need to place this isn't in a different. Yeah, let's try this. Maybe I have to place that in as a different argument. But let me just see now if it works. It actually works, but this did not happen, did it? It should chain those commands right there. Maybe we need. Maybe I need to do something like colon. Yes, this means that this is another command that I'm running here right here. I could also split this one up actually because there's a space right there. I think I'll leave. I think I'll keep this right there. Let us try this now. Let me just try this. Yes, I'm experimenting a bit now. That's because I have actually gone through whatever I want to show you today. But let us just see if it works now. Oh, it does not run this part right here for some reason. I need to figure out why. Does not. That could be another funny thing. Chain. But when I'm chaining, then I don't need to. Yeah, that's okay. I'll play with that another day. But thank you very much for watching. Let me just check. There was more optimizing. Yeah, we talked about all of it. And okay. That's just another thing. Let me just finish that. If you want to read up on other stuff, let's say that you know all of these things right here. Then the next step from here is actually Docker Compose. Then you instead of having, you can see I'm running these small shell scripts right here. I'm running these commands, and those. It can be a little bit annoying, of course, and of course you want it to be source code that you can actually place inside your Git repository or your Mercurial repository. And the way to do that is actually to create Docker Compose files instead, and then you use Docker Compose to start your application instead of Docker. This is just the basic way to actually start and stop Docker. And many times actually on Docker Hub, it will actually also tell you how to actually make a Docker Compose file that matches that can start up the application. Yeah, look right here. Here we have here's an example of the Docker Compose.yml file. So install Docker Compose and then and then look into that. But it is important that you understand the basics that I just told you right now. You need to understand ports, volumes, mappings. You can also add environment variables. Actually, you can place those inside the running container. And then network is also something that I did not go through that much right now. That's also something you can read up on. Then the other thing is, then when you're done with that and when you understand Docker Compose, then you should try to understand. Kubernetes. That's a huge subject, but that is the next step if you want to become even better with containerization and try to learn about Kubernetes. And there's also something called Docker Swarm. That's also quite good. You can also read up about that. But I think Kubernetes. I think Kubernetes is a little stronger. It can do a little bit more with that. But that's my opinion. Docker Swarm and Docker and Kubernetes. Those technologies will help you scale up and scale down the number of pods or containers, if you will. The containers actually live inside a pod, so those will spin up extra pods whenever it's needed, performance-wise. So that means that suddenly, if 90% of the CPU for one of your pods has been used for your web application, then a new one will automatically spawn up, and then your customers, your users, will not experience any lag when they visit your with your application. It can scale automatically. You can do a lot of cool stuff. That's enough for tonight. Thank you very much for watching. Have a great evening, and I hope to see you again soon as usual. Bye-bye.